have seen the forms, crystal forms, how they were formed with different making of different sizes, shape. As per that, it is going to be formed. There are various types of forms we have seen: simple form, compound form, closed form, open form, and limiting forms. General forms also we have seen. According to that, there are different types of crystal forms we need to talk about that. That is very easy. The isometric, tetragonal, orthorhombic systems. That is today we are going to see about that. Isometric or cubic, we see. In this system, it's we are calling it is actually the isometric. Actually, we are calling that is the cubic system also. Crystals where it is formed, where they are divided of a singular axis. They have three crystallographic axes, which are all in equal length, and the angle it should be 90 degrees. The axes are named. So you know that A1, A2, A3. A3 and axis, the front and the back axis, we are calling that is A1. That's the A1 axis. The right hand side, the terminal is negative, actually it is negative. And three axes are interchangeable. These axes are shown tetroid, inversion tetrad, and diasymmetrical planes. The planes the normal to this axis are called axial planes. These crystals have invariant four triad axis. It is showing the triad of inversion of the triad symmetry. This symmetry it is called as a terrestrial symmetrical plane. Almost all the crystals formed in this isometric system or a cubic system, and it's a closed form, and we were not able to found the non-isometric systems. This system it is has a 5 crystal classes. That's one. It is a detesseral inversion class. Second one is tesseral inversion class. And third one, it is based on the polar classes. It is a detesseral polar class and tesseral holoaxial class and tesseral polar class. It's a detesseral inversion class or a normal class or a grainer type. If you see here, actually cube it has 6 faces. Cube it has 6 faces phenotype. And otherwise, it's called as a hexahedron also, and which occurs alone in crystals. Faces are the square shaped. The mirror symbol of this form it is 100, which is right. That's 100. The 3 axes passing through the centers. You see here, the 3 axes is passing through this center. It's passing through these centers of the face, and the forms are which are called as the cubic axis. Right. Here each face it's cuts. See, each face it's a cutting, and one of the axis and it is a parallel to the another. The remaining two axes. When you compare with this first one, the first one it is a cutting the two axes and it is a passing through this center. And these axes coincided with the crystallographic axis. So the symmetry planes normal to these axes, it is called as the axial plane of the symmetry. Second one, if you go to the second one, it is a octahedron. It has 8 faces. You see here, this is a octahedron. It is a simple form, and it's yeah. It's a octahedron. It has 8 faces, and it occurs alone in a crystal. Faces have the shape of equilateral triangles. The Miller symbol of the form is triple one. In previous, it was in a cube. What we have seen that is a 100, and here it's a form. It is a triple one. The 4 axes passing through the centers of the faces of form. It's a we are called that is as a octahedral axis. You see here the Miller index triple one. It's a passing through 3 corners. 3 corners. So that we are calling it here the index. It is showing as a triple one. The 4 axes passing through the centers of the faces of the form. It's called as an octahedral axis. And these axes are show it's an inversion triad symmetry. Next one, it is a dodecahedron. The dodecahedron has 12 faces, and it is we are calling in another name. It is a rhomboid dodecahedron, and it occurs alone in a crystal, and it's a face which is a rhombo shaped. Rhombo shaped. Okay. It was not mentioned here, but And so passing through the Miller symbol, it is the formation. It's a double 1 0. Double 1 0 means here it is a passing through two centers. The axis is a passing through the two centers. So it is intersecting the two centers. So that it is indicating as a double 1 0. Next one, it is a tetrahexahedron. Tetrahexahedron. Hexahedron means it's a 6, and tetra means it's a 4. We see that is the 6 into 4, 24. It has a 24 faces. It is a solid body bounded by 24 isosceles. So that it's automatically it is showing the 24 faces. It's creating the 24 faces. The faces have the shape, and the form is look like 4 faces, which are arranged on each of the 6 cubic faces. The Miller symbol of the form is HK. Should write HKO, where H less than K, and within your braces, it's passing through the two centers, and additionally the side one will be creating, and the another axis it is passing through this one. So here it is indicating the Miller index, that is a 210. And the spaces of this form, it's a lie in the zone containing cubic and dodecahedral faces. And next one, it is a trisooctahedron. This one, let's see, this trisooctahedron. How many faces it has? It has again 24 faces. It is also called as a trigonal trisooctahedron. And when it occurs only alone in a crystal, the faces have a shape and isosceles of triangles. It looks like the form as if 3 faces supposed to be arranged on each of the 8 octahedral faces. The Miller symbol of the form, it is showing as HHL, where the L it's greater than by H. So it is indicating that is as a 2 to 1, showing 2 to 1. The faces of this form lie in the zone containing octahedron and dodecahedron. Another one, it is Iso Tetrahedron. This has a tetragonal octahedron, or a trapezohedron also. It occurs alone in a crystal, and it has a faces. The faces have the shape of a quadrilaterals. The Miller symbol of this form is HLL, where H is greater than L. And the Miller index is showing as L is equal to 1 and H is equal to 2. So that it is showing as 2, 1. The faces of this form lie in the zone containing the cube and octahedron. Hexaoctahedron. In a hexaoctahedron, it has 48 faces. When it occurs alone in crystal, face have the shape of a scalene triangle. The Miller symbol of the form it is known as the HKL. Where HKL is a 321. 321. The form index is showing a 321. And what are the examples for this crystal system metals? The first one is galena. Galena. Galena is the formula PBS. It's associated with the lead sulfide. And next one, it is a sodium chloride. Its mineral name, it is called as a halite. And third one, it is magnesium oxide. It is a ferriclase. Fourth one is manganese sulfide. That is albandite. Fifth one is CaF2 chloride. Sixth one is a spinel. The magnesium aluminum related. Magnesium it's consisting of alumina. Magnetite. The magnetite is we know that Fe3O4, chromite, FeCr2O4, analcite. It's a sodium silicate and sodium silicate along with alumina association, including the water molecules. Analcite. These 9 types of categories. One more so there, sodalite, almandine, diamond. The pure diamond is completely having the C carbon oriented. Next one, it is almandine. In a almandine, the chemical composition of this almandine, that is Fe plus 3, 2Al2, Sa3O12, and other garnets will be adding gold, arum. We know that gold, arum means Au, that's composition. Copper, so C, cuprate. And these are the best examples for this system. Next, coming to the tetragonal. In a tetragonal, the crystal system is characterized by having the only one singular axis, which shows the tetrad and or inversion tetrad symmetry. The angular axis coincides with the vertical crystallographic axis, RST axis. Definitely, we know that the ABC axis, which are passing through these crystals, the imagined lines, and it's intersecting the one point in a center point. The 3 points, the 3 axes are intersecting and passing through this. The A1 and the A2 axis lie in a horizontal plane and make angles of 90 degrees to each other. A1 axis is the front to back axis. A2 axis is the side to side axis. The front terminal of A1 axis, the right hand side terminal of A2 axis, and C axis will be also there. Yes, it was in the top terminal. The other terminal or negative, the 2 horizontal axis are changeable. And again, same as usual, it's also classified as 7 type crystals. That's ditetragonal equatorial class, tetragonal equatorial class. Third one is ditetragonal polar class. Fourth one is the tetragonal polaxial class. Fifth One is a tetragonal polar class. Sixth one is a ditetragonal inversion class. Seventh one is a tetragonal inversion class. The ditetragonal in equatorial class or normal class, or we are calling that is a zircon type also. This class, it is we know that that is we are calling normal or holosymmetric or holohedral class. As a trigonal bipyramid is the general form of the class. It is otherwise called ditetragonal pyramid class. The zircon, it is the best example for this one. Zircon is the principal mineral, and it's belonging to the particularly this group only or this class only. So that we are calling this type of the class, it is called as a zircon type class. Yeah, the symmetrical axis, it has a 3 planes of the axis and 2 diagonal. Totally 5 plane axial planes. 3 it is axial, 2 it is diagonal or diagonal axis or 5 planes. In center it's 1. In short, the symmetry elements are 1, 4 by m, first 4 by m, second 2 by m, and second again second 2 by m. It's a Hermann Magium symbol is 4 by m, 2 by m, 2 by m. The vertical crystallographic axis should coincide with the tetrad axis. The horizontal crystallographic axis may coincide with one or other 2 sets. So as per that, we see again some basic formations. One, it is a basal phenocoid. One, it is a basal phenocoid. In the basal phenocoids, it has 2 parallel vertical faces. And these faces are parallel to the vertical axis. And the B axis are normal. And it is a horizontal of the A axis. The symbol of form, it is 0, 0, 1. 0, 0. Because of first 2 axis, it is not intersecting. And second, third one, it is intersecting and through the center point. So that it is showing as a 0, 0, 1. Yeah, here the front phenocoid. Yeah, front phenocoid. It has 2 parallel horizontal faces. It has 2 horizontal faces, top and the bottom. And these faces are parallel to the horizontal A and B. The A and B axes are normal to the vertical axis. The general symbol of this form, it is a 0, 0, 1 for the free crystallographic axis of a system. And that is indicating as a 0, 0, 1. 0, 0, 0, 0, 1. For a 4 crystallographic axis, the symbol it is showing. And second one, it is side phenotype. The side phenotype, it is the opposite sides too. It's the 2 opposite sides. Here the picture, it is given top. As well, it should be top and that should be down. The faces are parallel to the C vertical axis and A axis and are normal to the V horizontal axis. The general symbol of form 0, 1, 0, one can observe that the side phenotype, it is called as a Bhoopathi phenotype in the orthorhombic system, while it's the name as the cyanophenotype to the monoclinical. Yeah, tetragonal prism first chart. In the tetragonal prism in the first order, it has four faces, and it's an open form. The zone axis coincides with the C axis. The Miller symbol of form is the G1, 0. The faces cuts the horizontal axis at the unit distance. The tetragonal prism second order, it's also same as usual as it has four faces. It is an open form. All the faces of the form, it's lying in one zone. The zone axis coincides with the C axis. The Miller symbol of the form is 100. Each of these faces lies parallel to one horizontal axis and normal to the other horizontal axis. Depending upon the choices, the horizontal crystallographic axis in order prism becomes second order prism. And next one, it is a ditetragonal prism. In a ditetragonal prism, it has a four and four, actually, 8 faces. All the faces of the form lie in one zone. The zone axis coincides with the C axis. The Miller symbol of the form, it is the HKO. That is H, it is greater than K. H, it is greater than K. The best example of this system, some examples, we see that it's a rutile. The rutile formation, it is a TiO2. Rutile form by it is a TiO2. Anatase, same anatase that's also having the same composition, TiO2. Case it right there. There is a SnO2. Pyrolusite. The pyrolusite, it is a magnesium, manganese oxide, sorry, manganese oxide. And previous case also, we have a one example from the manganese sulfide. That is a Alan bandage. It is the best example for the cubic system. It's a manganese sulfide, and it is a pyrolusite. It is a manganese oxide. And one more, it is a calomel. The calomel, it is a mercuric chloride. Yeah, zircon, we know that zircon prefix, ZrSiO4, and Westvinite or idocross. Yes, some prisms we see here, some prisms. The prisms are open forms, these are all, and it's combined with other forms to cover the space in a crystal. These are occur in all the non-symmetric systems. Apart from the triclinic system. Prisms are characterized by all the vertical irregular faces lie parallel to the C, vertical axis, and normal to the 1 or 2 or three horizontal axes. They may contain the 3, 4, 6, 8, or 12 faces. The prism are described in different ways. It's based on their faces and face numbers and the nature of a cross-sectional area. Depending on that, it's divided into the 7 types. The first one is a rhombic prism. In a rhombic prism, the form of 4 vertical faces and its cross-section is a rhombus. The side and the alternate angles of a rhombus is equal. The form only occurs in the orthorhombic and monoclinical system. The tetragonal prism, the prism has 4 vertical rectangular faces. See here, this picture. It has 4 vertical rectangular faces. You see here, this is the first side, second, third, that side, and fourth, that side. 4 faces it. The vertical rectangular faces per pair. See. And each angle is perpendicular to the square. So that's automatically the 90 degrees of square it is going to be made. The form only, it occurs in a tetragonal system, which is occurs in only a tetragonal system. The next one, it is a hexagon. In a hexagonal, it has 6 vertical rectangular faces. You see, 1 this side, 2, 3. And the front side, it is appearing as 3 faces, and back side means that the other side, it has 3 faces. So that's 3 plus 3, so 6 faces. The sides and the angle in the hexagon cross section are similar. The angle between the 2 adjacent sides in the cross section is 60 degrees. The form only occurs in the hexagonal system. Next one is a trigonal prism. In a trigonal prism, it has also same 6 vertical faces. You see, 1, 2, 3, 4, 5, 6. And these faces which are intersecting with the 2 pairs, 3 alternate edges, making 3 diagonal planes. Such forms is known as a trigonal prism. This form only occurs in the trigonal system. And ditetragonal prism, the form has 8 like faces. It's right parallel to the C vertical axis. And so cross section, it has 8 sided with equal sides and equal alternative angles. This form, it is a confined to the tetragonal system. The dihexagonal prism, in a dihexagonal prism, it has 6 to 12 faces. It's definitely it has 12 faces. 12 faces. All the faces are parallel to the vertical axis of the sea. You see, vertical. It's parallel to the sea. It's parallel to the sea axis. The bipyramids. In a bipyramids, which are closed forms. The closed forms, it's made by the intersection of a two conjugate pyramids. They are characterized by the isosceles or scalene triangle faces, which meet the sea crystallographic axis at two extreme corners, vertical and horizontal symmetric planes of the form. The forms which are occur in all the non-symmetric, non-isometric, other than the monoclinic and triclinic system. They may contain 6, 8, 12, 16, or 24 phases. Bipyramids are variable and described in a different ways based on their phases, numbers and others. Next, coming to the trigonal bipyramid. In a trigonal bipyramid, it has a 6 isosceles triangles, and it has a cross section, and it is an equatorial triangle. It occurs in a trigonal system. Yeah, this is a picture of that one. Next one, it is a tetragonal bipyramid. It has 8 isosceles triangle faces. You see, it's top down, 4, and top it has a 4, and down it has also 4 faces. Next one is the orthorhombic bipyramid, and this is also having a same 8 scalene triangle faces, and it's a cross section to the rhombus. It is a closed formation form and occurs in the orthorhombic system. Please wait 1 minute. Yeah. Ditetragonal bipyramid. In a ditetragonal bipyramid, the form it has a 16 scalene triangles. see here. This is a scalene triangle. Here, it has a 16 types, 16 triangular faces, and its cross section is an 8-sided. You see, this is 8-sided figure. It makes equal alternate angles. It is a closed form and occurs in the tetragonal system. Next one, it is a dihexagonal bipyramid. In a dihexagonal bipyramid, it has a 24 faces, and its cross section is a 12-side figure, and it's make equal alternate angles. It is a closed form and occurs with the hexagonal system. The Rhombohedron next is in Rhombohedron. This form, it has a 6 faces. Each face is a rhombus. Each face it looks like it's a rhombus. These faces above and 3 faces below. And it's joined together along the zigzag outline. And to give the closed pyramidal form, such form it is known as a Rhombohedron. And this form it is occurs in a Trigonal system. Next one, it is a Scaleno Headlock. Yeah, in this Scaleno Headron, it has a 12 scalene triangles. You see this scalene triangle. Yeah, and it is 6 faces are above and 6 faces are below. It was arranged sketch, and which is joined together along the zigzag line. This is the zigzag line. This line, as per this middle line, what we are observing here, as per line, along this line, the top side of a crystal face and below the crystal face, they were joined through a zigzag line. Next one is a dome. Yeah, this form, it is an open form, and it's consisting of 4 faces. Each face, it's cuts the vertical one and one of the axis, and it's a parallel. It's a parallel to the other remaining horizontal axis. It has been performed axial plane of symmetry and their axis of symmetry. The form only can occur in the orthorhombic and monoclinical system. And this form, it is also 2 types. One, it is a front dome. Second one, it is a side dome. The front dome, it is indicating the vertical axis, how they are passing through the crystal system. And the horizontal, and also as it should be the parallel to the axis. The parallel B axis, it is the move to the parallel to the micro axis and inclined to the and C brachy axis in the case of orthorhombic system, and parallel to the ortho axis and inclined to the C and A Scaleno axis in the case of monoclinic system. The front dome may be called as a macro dome. The side dome, in this form, the face cuts the vertical axis and the horizontal axis and the parallel to the A axis. Which is the meaning by that they are parallel to the brachyaxis and stay inclined to the C and macro axis in the case of orthorhombic system, and parallel to the Scaleno axis. As per that, the dome, it may be called as a brachy dome in the orthorhombic system. Then it is a Scaleno dome. It is in the monoclinic system. As per these crystal system classifications, we may find and we may know which mineral it belongs to in which category, or which mineral it is a falls under which symmetrical system. Okay. The next one, it's monoclinic, triclinic, and hexagonal systems. That is, we'll discuss tomorrow. But just I'll start the introduction. Just now we discussed about the isometric tetragonal orthorhombic crystal systems, and remaining crystal systems we are calling that monoclinic, triclinic, hexagonal. These systems we are going to discuss. In general, the monoclinical system, all the three crystallographic axes, which are different in their length. Three axes are in different lengths. The angles between these three axes are between a B and A axis. It is a 90 degrees. It's the intersection at a center point and pass through the center point. It's a perpendicular to the one axis to the another. So that definitely it is recording as a 90 degrees. The angle between the C and the A axis is not equal to the 90 degrees. In triclinic system, all the three crystallographic axes are unequal lengths. And it's also make the angles 90 degrees. And again, when you go into the hexagonal system, they're all together four crystallographic axes, and then yeah. It's a mono clinic system. If you go into the very detailedly, The crystals in this class have its innumerable singular axes. All the axes are confined to one single plane, and the axes are normal to that plane or a singular axis. So that here, the singular axis is a perpendicular to the other plane. It's called as a B crystallographic axis. The A and C crystallographic axis lie in the plane perpendicular to the B axis. The angle between B and C, the angle between B and C axis, or between A and B, maybe it is 90 degrees because it's a perpendicular to each one. So that automatically it is created, or it's creating the 90 degrees. The angle between C and A axis is not equal to the 90 degrees. It's designated as a beta. We are showing that is a beta. So this is the formation of the angles here. The angle between the C and A axis is not equal to sometimes 90 degrees. It is not showing. So that at the time we will showing the axis. It is as a beta, alpha, beta, gamma, like that. Beta symbol. With the beta symbol we have to show. The front to back axis it is a A axis. Side to side axis is a B axis. The vertical axis is a C axis. We know that. The front to back axis, it is a A axis, and side to side, the side to side, it may be horizontal, and that is showing as a B axis. The vertical axis is a C axis. As A axis, it's inclined to the vertical axis. It is called as a Scaleno axis. Called as a Scaleno axis. So now B axis, it's making the angle between 90 degrees, and it's between vertical axis, that is the vertical line of C. It's called as a ortho axis. The front terminal of A axis are positive terminals. The other terminal are negative. Although the position of a B axis is fixed, the choice of A and C arbitrary. Okay, and I'm stopping here. Tomorrow we'll discuss about the remaining description. That's about a monoclinic, triclinic, and hexagonal systems.